Doug runs research for Corning's automotive glass operations. But what I'm going to do is I'm going to turn it over to Matt, and he'll tell you about what we're up to with lightweighting beyond F-150.
All right, thanks, Mike. Hey, thanks for joining us. The title of this is called Lose It. Why? Because Detroit's on a diet. You got to take weight out of our vehicles. If you look at our product lineup, we've got some phenomenal engine technology. EcoBoost, democratized across the board. Now we're turning our attention to taking out weight. This is a major element of our overall strategy. You've probably read, we've said we're going to take anywhere from 200 to 750 pounds out of our vehicles. That's not just words on paper. We're doing this today. What I do is I try to look at all materials, steel, aluminum, composites, magnesium, and the manufacturing technologies to take that weight out. And I'll give you a couple of clues. When we started working on aluminum 20 years ago, people were saying, that's great, you put it on some specialty vehicles. Today it's on our F-150. That's one of the highest volume production vehicles in the world, and it's all aluminum. 700 pounds, it's all about performance, and you know, we don't take any chances with that product. That's a state-of-the-art truck, state-of-the-art materials, and it's delivering what the consumers want. But now let's talk about other materials. We can work with steel, we can work with aluminum. The vehicle behind me is actually a Ford Fusion. What's unique about this is we took almost 800 pounds out of this vehicle. This Fusion is the weight of a Fiesta. That's a significant amount of weight savings. Well, I'm going to talk to you about all the materials and how we mass decompound. If we take out the right amount of weight in the right areas, like the body, the chassis, we can take additional weight out of the engine, and we can downsize the engine. This vehicle here, instead of a 1.6, it has a 1-liter EcoBoost engine. It's a huge step in the right direction. So not only did we reduce the weight, we took the weight out of the engine. And there's a lot of cool technology behind it, and I'm going to step you through some of it. Now, we talked about the aluminum vehicle, we talked about an F-150. I will walk you past the Ford GT. That's really pushing the envelope with carbon fiber technology. But before we do that, if you look at this vehicle, the current Ford Fusion is primarily steel. This is about 2/3 aluminum and about 1/3 steel. So what we did was put aluminum where it made sense, steel where we wanted, but we pushed the envelope. This is us going further. We'll talk to you about this with our colleagues Corning. This is Gorilla Glass. This is the type of glass that's on every one of your cell phones. If you have a state-of-the-art cell phone, it's on your cell phone. But this has carbon fiber wheels, it has composite springs, it has material exactly where you want it. We are agnostic. We put the right material in the right place at the right time. So this vehicle is all about mixed materials. Now I wanted to talk about some of the individual materials. Taking your eyes off the car, these are some very unique components that you're going to see here. This is a carbon fiber wheel. This is actually going on some of our future products. This is going to go on our Mustang GT350R, 40% weight saving.
How much?
By the cars. It's expensive. But what our job is to take the cost out where we can.
So we're not talking production, we're talking cost saving.
We're talking weight savings.
Weight saving.
Weight
not
savings.
cost saving.
Right, that's why it's going on a performance car. We've got some other interesting technologies. You wouldn't expect to see a composite spring, but this has passed all of our durability testing. This is a glass fiber composite spring. It's gone through corrosion, it's gone through durability, and it's gone through crash testing. These are some unique materials that we're working on today for future products. This is what our mission is. As I walk around here, I'm going to try to get you to take a look at some of these. I'll tell you what, I'll just hold them, it'll be easier. Today, our engine blocks have supplemented a die-cast oil pan. We're also looking at a carbon fiber injection molded oil pan. This is a 33% weight saving. So you can see we're trying to teach an old material new tricks. Never before have we done a structural oil pan out of an injection molded component. But some new materials like carbon fiber allow us to enable that. This is pretty cool technology about taking weight out of our vehicles. There's a number of other components here that you might find interesting. Some of our engine blocks today are made out of aluminum, and in order to provide the wear resistance for the cylinder bore, we actually put a cast iron liner into the cylinder. This is actually a coating. This is an aerospace type coating that we invented at Ford Motor Company, and instead of a 2 or 3 millimeter thick cast iron liner, that's 100 microns. So that's a 1/10 of a millimeter thin coating. That's a hair. That's a very thin coating on the inside of the cylinder bore wall. It delivers wear about 100 microns, about a 1/10 of 0.1 millimeters. So it's a wear-resistant coating that provides the functionality, the heat exchange, heat transfer, and yet it's us going further.
It'll keep the thickness, I mean, it's very thin.
Yeah, the wear resistance of this coating exceeds the wear we would get on cast iron. Again, this is a material technology going further, us pushing the envelope. How about some of the rotating mass? We have a lot of components in our car that rotates. I got brake rotors here. Instead of making, I'll let you do this. That's an aluminum brake rotor. Pick up that one. That's cast iron. Tell me the difference. All right, that's enough. I don't need that to give you the weight save. But how about things like connecting rods? This is a traditional connecting rod. This is a forged aluminum connecting rod. That takes a kilogram out. If I have a 3-cylinder engine, that's 3 kilograms. See, the math adds up real quick.
1 kilogram per rod.
Per rod. That's a lot of weight savings. There's another demo that I can do for you, which is rotating mass. I'll choose somebody who wants to try this. Take that. Feel that one.
How about cost?
See the difference? All of the technologies we're looking at here have a price point. What we're looking to do is take the cost out with advanced manufacturing. This happens to actually make some pretty solid business case because we're eliminating a step. This is laser welded, this is friction stir welded. So we're adding the lightweight material, we're taking out cost where we can. Now what's unique about materials is we have left no material untouched. I talked about steel, I talked about aluminum, I talked about carbon and magnesium. What I want you to do now is I want you to turn around and I want to introduce you to Doug and some of the really cool things we're doing with Corning on glass. Things that boggled my mind, and I'm glad that you're partnering with Doug. Doug?
Thanks, Matt. Hi, everyone. Like Matt said, my name is Doug Harshbarger. I work for Corning Incorporated. We're a company from upstate New York, about 164 years old. Our expertise is glass and glass materials. Many of you may know us from consumer products like Corel and Pyrex. But frankly, today, most of our business is in what we call highly technical glasses. And Matt gave me an example of the glass that goes on the surface of many mobile phones today is a glass called Gorilla Glass. Also, we've worked in the automotive space for more than 40 years at this point, bringing new technology solutions to solve the sort of problems that crop up from time to time, lightweighting being one of them. So, as an introduction to what we're doing in lightweighting, I'd like to get a volunteer from the audience to experience Gorilla Glass firsthand. Come on over here. So I imagine you probably own a cell phone like this, and maybe you've heard of Gorilla Glass before. What I want to show you is a comparison in strength between typical window glass, soda lime glass,